did not parse right, but I'm fine with it.
It's fun how they all come together sometimes like that.
Welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 253, More Wood Robot, Glitching and Fuming Nitric Acid, and We Heart USB-C. This week's news, we got lots of space news. Take it away, Tom.
Things on the way to the moon are getting busy because they aren't all making it there, unfortunately. The moon might look like it's not so far away, but arriving there is still quite a challenge. So we covered last week the Peregrine lander, but not a lander. They ran into a problem pretty much immediately. If there's a school of thought that says, it's good to fail early so that you get that disappointment out of the way, they definitely took that route because it was like, turn it on, that blew up. They've been super transparent, which is really cool. I think you could say that about a lot of the new space companies. There's a lot more detail out there, and I get it's probably because of social media, and they know they can't stay quiet like it could back in the day when people were waiting for a newspaper, right? They're very formal letterhead pictures that they put up on social media. But the last one said that it seems like the pressure in the propellant tank went way higher than they expected because a valve didn't close or something. And the tank ruptured, and then that let out a stream of pressurized gas, which basically acted as its own little thruster and just kept the thing moving in a weird way. So they were never able to really get stabilized, which means they were having trouble charging the batteries, and since you can't really predict where it's going to go, they couldn't make the kind of course corrections necessary to get to the moon. Long story short, the moon landing never happened, and now, by the time you'll have heard this podcast, it's expected that the Peregrine lander will have burned up in the atmosphere. They had the chance to kind of just fling it into deep space, maybe not as accurately as they would have liked, but they could have just, kind of dropped the throttles and gotten away from Earth.
I hope it goes somewhere.
They said that that's somewhat frowned upon, just sending things careening through space. So they said they'd rather it burn up in the atmosphere and be responsibly, disposed of, which is obviously it's the right call. It's the disappointing call because there was a lot of scientific payloads on there that were, even if they couldn't land, it would have been nice if they could have got, some time in deep space and information could have been pulled in and sensors could have been tested and all that kind of stuff. But, it's better to just have these things responsibly taken care of. In the past, we were kind of cavalier with that sort of thing and just threw stuff around the solar system and maybe it'll come back, maybe it won't. And these days we try to avoid that. But in the wake of one failure, well, actually, I guess it's early to say comes a success, right? Because we don't know. But on Friday morning at around 10 a.m. Eastern, so that's the podcast will have been out for an hour by then, I think. A Japanese lander will be trying to come down on the moon, and if the timing works out and you're able to watch that live, that would be cool. Or perhaps this has already happened and you'll know more than we do now what the end result was. But things are getting busy. There's another American lander supposed to lift off next month. This is the idea, right? That there was going to be this rush of stuff happening on the moon and this commercial ecosystem where everybody's trying to land and do stuff. And it's cool to see in a way. We were always kind of promised this, buzzing space economy that seems like it's finally developing. It would be even cooler if they worked, but we'll get there, right? These are the early days. It's also important to remember because obviously comparisons always get drawn. Well, we did it in Apollo and da. But those were much bigger, and the Apollo lander was way bigger, way more complicated. These are they're commercial in nature, right? So the order of the day is getting them as cheap and small and simplistic as possible. So you're kind of in this thing where all these companies are trying to figure out what's the minimum required to forget redundant systems, forget real-time control. You need something that can basically just throw at the moon and it'll land itself. And it's going to take time to figure that out. But once they have it down, it's going to be, you'll be able to put stuff down for way, way cheaper than we were in the past. And that's the end goal of, we're not going to be able to do anything on the moon if it takes $1 billion for every lander,
Talking to Dan about it a few weeks ago on the podcast because I think it was your article actually about the in-space refueling tests. He had a really neat perspective on that, these are just kind of all the challenges you set along the way. And of course, they're all impossible until you go out and try to do them. And he was
absolutely.
like, it was kind of cool because he's like, this is what it was like during, the first round through. It was like, hey, can we do this? I don't know. Let's try it. And then we'll engineer our way around this problem. And then we'll
Yeah.
engineer our way around that problem and this problem and that problem. And I thought that was a neat perspective on this because I've heard a lot of stuff in the internet in general where people are bleak about these things. They're like, oh, this has never been tested before. Like, that's a problem. And I guess it is a problem if you really need it to work. But, like, that's also how you learn, right? Like, if we knew how to do it, we wouldn't be learning something new. And I think that spirit of the space program is actually super, super important. The kind of learning new technologies so that we can apply them is like, that's a good half the game.
Hopefully there'll be a time where we look back at it and be like, oh yeah, remember when that was something that people had worried about, and now it's relatively commonplace.
Well, with absolutely no possible segue, let's head on over to What's That Sound?
Yeah, right.
This is a journey into sound.
What's that sound?
What's that sound?
Oh, okay. What? Is this like Halloween sound effects volume 2? you know, for the first few seconds, I was like, "That's a camera," and then then there was a car alarm, and then I don't know, dogs. That was kind of all over the place.
It's supposed to be like sawing, I think, and then that last one was supposed to be a chainsaw.
Oh yeah, definitely chainsaw. Is this like something you use to test your sound system? Really run it through the paces.
Oh, I'm gonna have to get one of those old like sound test recordings and run that sometime. Yeah, totally. Is that your final answer?
I think that's as good as I'm gonna get. Yeah,
it's a bird.
That's a bird?
It's the lyrebird mimicking noises that it heard. And this is from a fantastic old Richard Attenborough documentary. Jono wrote me on Discord and said, A, first of all, that's the lyrebird, but B, did you know that documentary was filmed about a bird that had lived in a zoo and had been exposed to all these noises, and it wasn't actually like in the wilderness, that one, but
all right, well, that makes
in
more
a
sense,
zoo.
I guess.
He'd been around too many people and had been trained on all these sounds. But no, it's absolutely stunning mimicry.
I mean, mission accomplished, right? I absolutely thought it was a car alarm and chainsaw and all that stuff.
Well, we'll throw the link in the show notes. It's absolutely fantastic.
And what is the reason that the bird mimics these things? Is it like a defensive?
No, this is
to scare off predators or something.
It's a mating dance thing. The bird shows as wide a repertoire of noises from the jungle it can do, and that supposedly attracts more mates or something.
All right.
You know.
I mean, if a chainsaw gets you going, I suppose that'll work, right? Well, they don't know it's a chainsaw. They just think it's a funny noise.
Anyway, apparently a lot of people had seen this documentary because we had something like 60 responses, 42 of which are correct. And correct enough that they said lyrebird, not just a bird, which, for the record, was Christina's answer last week. So,
oh wow, she got as good enough to be a bird.
I gave it to her because I thought that was good enough. But so many people, 42 people said lyrebird, so that has to be the correct answer. We'll have to throw some other links in here. There's a spoof on this David Attenborough documentary that's actually pretty damn hilarious. I'll throw that link in as well. Thanks for that, Adam Smith, if that is your real name. The number of people who made puns on lyre, like the twiddling, like the stringed harp-like instrument,
like Spock plays,
and LIAR in the comments are absolutely ridiculous. We have liar, pants on fire, etc., etc. But yeah, tons and tons of people apparently recognize this documentary. Let's see. In honor of the bird, I'm going to hash up a file I have on my hard drive here, and it is the sound of a hacksaw that I was going to use for a What's That Sound once and never did. So here's the hashing hacksaw.wave, which just happens to be sitting on my hard drive. A few shows back, someone questioned me about whether I was remembering to add 1 because when you do modulo, it gives you a number between 0 and whatever. And adding 1's hard. So instead, I'm 0 indexing. So zero's in there. So this is 42 correct answers numbered from 0 to 41. Random hash hacksaw wave 42 gives me a syntax error.
Congratulations, syntax error. You'll be getting a Hackaday.
Syntax error, you win. What have I done wrong? This worked last time.
Man, I can't tell you how many times I've said that. This worked last time.
Aha. Number of contestants first, file name second argument. Here we go. Congratulations, number 26. Who is?
If their name is syntax error, I'm going to freak out.
Yeah, no. Congratulations to Pixie, Lyrebird Sounds, number 26. So, boom. I'll get in touch with you shortly, get a Hackaday t-shirt to you. Everybody else listen next week. I'll come up with another sound. We'll probably go back to machines again. Random bleepy bloopies. Well, I'd like to start off the hacks with a particularly wintry hack, Feeding the Fire by Robot. And this is actually, it's a 3-year-old series of videos, but I'd never seen it before, so I was stoked to see it, by Anders. And there are 12 of them, and it is all about him building a fire-stoking, log-feeding robot in his basement. This is the most marvelous low-tech robot you've ever seen. It's a hanging track from his ceiling, basically, and a gripper arm that goes and picks up chunks of wood stacked up in this, like, magazine that he's built, pulls it, pushes it over to his wood-fired boiler burner. There's another little kind of mini robot thing that opens the door, it sticks the wood in, pulls it back out, closes the door, and gets ready to do it again. He's actually got a temperature sensor in the boiler and in the furnace, so he's having this thing throw logs in only when they need to be thrown in to keep it hot enough but not over hot. But what's really neat about this is A, his super low-tech way of solving the problem, and then B, just how difficult it is. If you think about how to pick up a bunch of quartered logs, and some of them aren't even quartered, some of them are just kind of, a few inches in diameter bits of trunk, and then others of them are quartered, and it's really the randomest size objects to pick up. And he does it with a really low-tech robot, but with a lot of feedback in the system. And I think that's partly what I think is neat about it, is that he's just got a whole bunch of roller switches everywhere. So, like, the arm goes down until the switch tells it that it's found a log, because it doesn't know how many logs are in the stack at any given time. So it has to go down until the thing hits the log, and then it pulls in these 2 grabbers from either side of the log until they get enough force on them that they push a little switch, and then it picks it up and moves it out. But the advantage of this is then, because he's got a switch that knows if there's a log in the gripper, he can also tell if it's dropped it along the way, and it can go back and pick up another log and things like this. And in the early stages of development, he actually uses all this. Yeah, you just have to watch it because it's a fantastically low-tech robot, but it's also, he's kind of thought of all of the edge cases, and he's planned it all out. And because of that, it actually does what it's supposed to do, and that is feed something like 50 logs a day into his wood-fired burner.
I mean, it's very impressive, right? But it is interesting in that we've talked about this before. It's like a robot mimicking the human behavior rather than, taking what would have been the most obvious approach, right? And I kind of appreciate that instead of, as even mentioned in the write-up that, like a pellet stove, you could just do this by, dumping measured pellets into the thing every hour or whatever. Yeah. But like, what's the fun in that? This is, recreating what a person would do, opening the door, getting a log, pushing it in. The immediate advantage, right, is that you don't have to modify the stove, or I guess nothing permanent. You don't have to bust a hole in the side or anything. I mean, respect for going through all the effort to develop this. And all the little gotchas that you could run into, and it's super impressive for like the sake of being impressive, which I think is always like a classic Hackaday project, right? Like, like if they were always practical, like it wouldn't be as much fun.
Oh, this one really has the like flavor of I'm stuck in my basement in the winter throwing logs in this burner, and I'm just fed up with it. How can I start working on this? And I think it's probably, it's put together from stuff on hand, maybe. I mean, he must have gone out and bought a bunch of roller switches, but who knows what else?
Yeah, who's got that many just laying around?
But like some of the things where it knows its position because these, another set of roller switches is going against a track on the ceiling, and he has put little bits of wood in the track. So it rolls over these little wooden ramps to actuate the switch. Like, I mean, the thing is made out of the stuff it's moving as well. There's like a lot of wood and, threaded rod and et cetera, et cetera. It's kind of janky, but he points out that it's nice that it's kind of janky because it's compliant. And so when it hits him or it hits something, it kind of bends instead of breaking. And
right.
It doesn't kill anybody. And it moves slowly enough that he's not afraid to be in the basement with the thing at the same time. You could imagine one of those big industrial arms that would, pulverize you if it hit you. You don't want that in your basement, right?
With the added feature of fire being involved.
Yeah, exactly. This thing's totally gentle. It's really nice. He goes through the code in the video. He obviously is not a coder, and I mean no disrespect here. He has invented essentially the state machine himself because he figured out that that's what he wanted. And so he's got this essentially lookup table of function pointers, and he's like, you can go from here to here. And he says, the real advantage of this, of writing it this way instead of with explicit function calls, is that you can jump from one state to the other. Only he doesn't know the word state. Like, he doesn't have any of the programming background, any of the computer sciencey kind of background for any of this. He just invented it himself because it was the best way to solve the problem. Oh, super, super, super respect for that too. It's such a cool project, from all of that down to the like hand-rolled kind of home automation IoT panel that he made that's got like a sketch that he must have made on Paint or something, or on some, cell phone application of a robot feeding the fire. But at the same time, it's graphing in real time his boiler temperature and the times of last feedings of new wood into the fire. And you can actually see the whole dynamics of the system. Again, it's high-tech, low-tech, cobbled together, marvelous. And there are 12 videos of this for you to enjoy if you missed them the first time around.
Well, this next one is kind of a twofer. It is 20 years since the OpenWRT project has been out there, which is an incredible number. It doesn't seem possible, but, the legendary WRT 54G is that old of a router. If you're not familiar with the OpenWRT project, it is way more than just a replacement firmware for a single 20-year-old router. It has evolved considerably, and it is really its own Linux distribution for routers, and even other. I think at this point, the Raspberry Pi and stuff is like an official target. And if you need Linux on a little device, OpenWRT is probably a good choice. In honor of the 20 years of being out there and supporting new devices and just being awesome, there's a proposal to finally introduce their own properly upstream supported reference hardware. And I think this is really exciting. When it was just the Linksys WRT 54G, times it was easier. Like times were simpler back then. You could just go buy the one router and flash it. But if you've looked into these replacement firmwares recently, it is trickier. You have to really kind of do your homework before you buy anything to make sure it is supported by OpenWRT or DDWRT or any of the other kind of spin-offs. So I think it's really cool that there is going to be potentially like a known platform that you could buy and everything's going to work, and there's not going to be any like, oh, sorry, that part didn't work or that part crashes because we haven't got to it. Like, I think the project has definitely matured to the point that they deserve this. They deserve their own 100%. Something that comes from them is going to get legit support. There's no hacking around and waiting for some binary blob to be figured out. We don't know a whole lot about it. There's kind of theoretical specs are dropped in there. We don't know what it would look like. It doesn't look like it's going to, blow the doors off anything. This isn't some, mega super high-end router necessarily, but it's fine. It's a lot more powerful than the original Linksys WRT, that's for sure. I don't know that they've 100% agreed to this. There's definitely a lot of interest, and everybody seems to be on board, but, everybody being on board and actually producing your own router are two different things, right? So we'll have to kind of keep an eye on this going forward, but I think it's a very exciting time, and I really look forward to the day that I could just go and buy a router from them and know it's going to work, and know I'm not going to have to do any bust out the serial cable because I screwed up flashing it. It's going to be nice, and I'm really looking forward to what the future holds for the project.
I think it's so rad that they went from writing software to run on other hardware to eventually the software taking on such a life of its own that they're eventually building the hardware that will run the software, right? Like they're building kind of the optimal hardware for themselves in the end, which I think is really cool. I also have to say RIP my WRT 54G, which I actually had to put down last year or maybe the year before. It has been running from whenever I bought it, probably most of these 20 years actually, and I've been using it as my home IoT router because the low bandwidth, it's connected to a bunch of ESP8266s. Nobody cares that it's low bandwidth. It's really all right. And it's done me probably 18 years of service, and I don't even know what I had on it anymore. It's been through most of the open firmwares. It's definitely done OpenWRT. It's done DD. I think I might have had Tomato running on it.
Oh, yeah, I did Tomato for a while.
Again, that's also from 15 years ago or something. And it just works. So why screw around with it, right? Like I moved, I had to integrate it with a different network. I had to change a couple things and here or there. But, I probably am running 10-year-old firmware. That you probably shouldn't admit that. Well, the radio ended up burning out, so it doesn't work anymore. So you can't hack it. It's not even plugged in. Come at me. Mike gave a great talk at a SuperCon where he was like, what was Hackaday like 15 years ago? I think it was for our 15th anniversary. And, pointing out that back in the day, the WRT router was so crucial because it was like the only way to get something on Wi-Fi back then. And that it was also Linux and hackable made it, there were robots with a WRT box as the brain because it could also give them Wi-Fi. And then, you flash forward 15 years where you could pick up an ESP8266 for like a couple bucks and that solves that problem. Check, So it's really neat to kind of look back on that particular router from that perspective too. That the software has outlived the hardware and is now going to give birth to its own hardware, I think is absolutely fantastic. So good on them.
I should say too that they're aiming for under $100, which, if you've looked at what some of these modern wireless routers are costing, like $100 is nothing anymore. I mean, yeah, of course you can still get like the $20 or $30 little TP-Link jobby, but like any kind of decent router is shockingly expensive and runs, a proprietary firmware, right? And may or may not be able to be flashed to an open one. So for $100, I think there's absolutely a market there. I mean, you could argue there's probably even outside of the hobbyist. I mean, if you could say, hey, this is going to be a rock solid router and, we're going to be able to do all these features on it. And, there are some really interesting things on the feature list. They're talking about, a quote unquote unbrickable firmware because they're going to have two separate flash chips. Like one is going to back up the other. So if you bork one, you can always switch back to the other one,
Challenge accepted.
Yeah, right. Multiple antenna setups. There's like some kind of expansion slot. Like it's if you're into routers, and of course, like there's like anything else, there's going to be some group of like diehard router aficionados. It sounds pretty cool for $100, assuming they can hit that number. And of course, some portion of that goes back to the project because they do mention in the proposal that like OpenWRT themselves don't have the experience and the facilities to build this thing, so they would contract out to somebody. So there's obviously some profit sharing that has to go on because they have to get their cut. Probably worth mentioning, OpenWRT, it's a very long-lived and respected free software project, and they're going to make sure that is also represented in the hardware. So they haven't said what the license is going to be, but they are going to release the schematics at the very least, and everything's going to be obviously completely compliant with the GPL, and you're going to be able to, get the complete firmware image and the tool chain and all that stuff. So I think it's going to be really cool, kind of even as, an example of like just an open project done right. I mean, who better to do that than a group that has been working on the open software for 20 years at this point. So I think it's going to be really cool for a lot of reasons, and hopefully will be successful and will be something that we can point at and say, hey, here, you could do it. Like they did it. They made a successful open hardware device, and this is the framework to follow for that. If only your WRT could have held out for a little bit longer.
I know, it didn't quite.
It didn't get to see the birth of this glorious era.
I hope I've still got it kicking around here somewhere, so I can, at least hold it up to the screen so it can read it.
Look what you gave birth to.
Hi, well, if they're not going to give you open hardware, you can open it up yourself. Our next post comes from Hash. This is a video reverse engineering smart meters, now with more fuming nitric acid. And this video is kind of in two different places. One of them is detailing Hash's continuing smart meter obsession, but it also is kind of a brief technical tour into two things he's been doing recently. Sometimes when he's taking things apart and documenting them, he runs into chips that aren't labeled or are mislabeled, or he can't find the part numbers for. And if you want to find out what's inside, you can open the chip up. And so part of this video is kind of a deep dive into his DIY decapping setup, which includes using a microscope and a DIY microscope stage. So this is the open flexure delta stage. And so this moves the chip around once he has decapped it and allows him to take high resolution small pictures and stitch them all together so he gets a good view of it. But before you can do that, you have to get the thing out of its case. And that's where the fuming nitric acid comes in. He finds that buying fuming nitric is too expensive, and so he makes his own. And the chemistry is surprisingly easy, probably also dangerous. So be a little bit careful if you're repeating this. But it's basically sulfuric acid plus potassium nitrate makes nitric acid and whatever is left over, potassium sulfate must be. And then he distills off the nitric acid. And this is as bad as it sounds. This is, you boil off the nitric acid and condense it and collect it. But the effort is worth it because getting really pure nitric acid is difficult, and the more pure it is, the better it is, because the super pure nitric acid doesn't attack the metal that's inside the chip at all. So once you've gotten through the outside of it, you aren't destroying the bond wires, you aren't destroying the dye. So you've got a really nice, clean image. So you've done the decapping in a super clean way. The cleaner your fuming nitric is. The fumes of fuming nitric acid are, well, they're nitric acid fumes. You don't want anything to do with them. So that part of this is strictly do it in your garage and make sure you've got ventilation. And I would actually probably do it under a fume hood myself. But the distillation is actually pretty straightforward. The stuff boils like 80 degrees C. It doesn't actually look that bad. So I was kind of impressed that you could do it at all. I have always been scared of fuming nitric acid, probably for good reason.
Yeah, I was gonna say, I think keep that. I keep that in heart.
When you watch it just eat through the integrated circuit, you don't want that on your skin, right? Wear gloves, folks, wear gloves. But the basic takeaway from watching this video is that decapping ICs is probably something you could do at home with not a crazy outlay. And Hash's setup, both in terms of the disassembling the devices, he's got a really nice kind of light table setup where he's got a camera mounted so he can take pictures of the thing as he's taking it apart for documentation later. And that's actually an awesome first step. And then once he starts getting into the chips, he's got this whole decapping and microscope stage setup that's also really nice. It's just fun to see how, at least at this point, a lot of his reverse engineering effort is actually just really clever documentation effort and just like laying out all the pieces, putting all the pieces together And only then can you kind of figure out, how do they all interoperate with each other? What's going on here? And I think that's really cool about this video, aside from the making your own nitric acid, is just the kind of, assembling all the facts first stage and then trying to figure out how the device does what it does. I think that's a neat approach, and he lays that out really well here.
It's documentation as much as it is reverse engineering. And I guess there's probably a case to be made that reverse engineering is just like documentation by force, right? You're documenting something that ideally would have been documented already, but maybe it probably is. You just don't have access to it, right? So that is an interesting way of thinking of the whole reverse engineering process. Is like completion backwards principle. You want to end with documentation, and it starts with stump remover and battery acid. Like I said, despite the huge "don't try this at home" warning on the video, this is very much at home, and it is really impressive what you can pull off at home for decapping. We've seen a lot of decapping, more than I maybe would have expected. Still I would say a super niche kind of thing, but they're out there. People are out there doing it, and like you said, the setup is not impossible. It's not like you need some electron microscope or something necessarily. You can do this if you're so inclined, and I think it's cool that for the people who are sufficiently motivated, let's say, that the options are out there. I think it's always good to have options, things that we could do on our own terms. And even if it's something like this, where realistically maybe 4% of the people who are reading this will actually try to decap their own chip, but the information is still out there, right? And information is power at the end of the day. So I think that stuff like this is really cool to document and show what's possible, even if it is super fringe. Just the fact that we can see this, and we can see how it's done and how it can be applied is really, really exciting stuff.
And it doesn't have to be super fringe either. There's easier ways to do this than the nasty chemistry as well. And actually, I'll throw a link to an article, Chip Decapping the Easy Way, which was a video done by Curious Mark, where he took some old enough chips that the die on the inside is really big. He took these out of like an old PlayStation 1. All he does to decap this thing is put it over a hot air gun so that it warms up, and then he kind of bends it back and forth with a plier enough times that the case breaks off, and he's left with the die completely unharmed. There's just two pairs of pliers and a heat gun.
If only it was this easy.
There is no rocket science here. And because the chips are old enough, the die is big enough that even with just a handheld magnifying glass, you can see what's going on in there. And so, yeah, I do agree with you that certainly decapping modern chips, and especially like the super tiny feature sizes these days, the microscope you're going to need to analyze it is actually probably the hard part. But, you can play around with it for fun just by getting some crappy old hardware and snapping the chips apart. And B, if you do that, it might give you insight into, kind of the next steps and what you need to do to take them to get into some more reasonable chips. And again, the reason Hash was doing this here is just because he needed to identify some of these chips. And in the past, for instance, he's run into transmitter chips, and he's like, what is this part number? He doesn't know. He opens the thing up, and there with a microscope, you can see that it's a TI CC 1100 transmitter receiver chip, right? And so like a lot of stuff isn't really rocket science in the end. It's just, can you get into that package to get to the easy part? Must be a bunch of different ways to get to that goal as well. And, if you're shy of a little chemistry, find some old electro junk and bend it till it breaks.
But it's funny you talk about alternate methods to get here too. I don't know if you saw, I posted it in the Discord a day or two ago. I've been on a kick of let's see what I can put in the laser and see what happens. And I put an AT Tiny in there, and I wanted to see if I could laser off the silk screen and be my own little home shady hardware production, where I don't want you to be able to figure out what chips I've used in the device. And the answer is like yes, very easily. It was able to blow off the silk screen, but then like when I took the picture of it, because I took like a macro shot to show it, I realized it actually ablated a decent amount of the case off. And when I posted it, like somebody immediately sent me a thing like, yeah, but could you keep doing that and get to the die? And I was like, well, yeah, probably, now that I think about it. So, maybe that'll be another option too, now that these more powerful lasers are becoming, if not commonplace, at least more commonplace, right? That, maybe we'll see people doing that as well, just lasering the top of these chips off in some cases.
Oh, we have. Let me point you to an article on Hackaday. I've seen people do laser decapping both with, first of all, the obvious and the best thing to do is those epoxy blobs, right? That epoxy is really easy to shoot away with a laser.
Oh, I gotta try that.
Then you're left with the chip on the board, right? So it's really easy to get inside epoxy blobs that way, which you otherwise couldn't do. But here's a neat old article from 2015 about a guy who had broken a pin off of a 100-pin STM32 microcontroller, and to get at the pin, he lasered off with a decent size CO2 laser, the chunk around it where the lead frame wires go out to the pins. And then he got enough of that away that he could just solder directly to the lead frame and finish the connection up. Hats off to Karsten who did that. Results are awesome. I mean, that's a clean bit of work he got done there.
It is like just a perfect cut right out of the case.
And in this article, I linked to a talk at an old Chaos Congress 9 years ago now that's all about other alternative techniques to getting inside chips. And that's where Karsten learned about doing it with the laser, but there's all sorts of other things there, including grinding and some other non-terrifying acid methods of getting inside chips. So do it, folks. Don't be afraid.
All right, this next one I want to talk about is actually something of a rant from Jenny List, but I think it certainly resonated with me, and judging by the comments, a lot of other people agreed, so I thought we'd bring it up. This is USB-C power delivery, new technology done right. I really like USB-C. I'm not gonna lie. I'm fully committed now. I've moved pretty much everything I have, that I can think of to USB-C, and most of those things are using, power delivery for proper charging. And I would like to think that the days of weird DC converters and barrel plugs are past now, and that we can kind of continue on with this glorious unified charging standard. It hasn't always been an easy road, right? I mean, I think we've been talking about the arrival of USB-C power delivery for like 4 or 5 years, maybe, if you went back long enough and started looking at, I think there was even one that was like, USB-C is going to take over, but when? I'm pretty sure we wrote that article. I think Roger wrote that a couple years ago. So it's taken a while. It was not overnight, but these things rarely are. But I think where we're at now, and kind of what Jenny is getting at, is that we're in a very good place right now. And if you are still kind of you're holding out and you still got your micro USB or something else, maybe it's time to look at this stuff again. And I even kind of called that out in the year in review for 2023, is that there was definitely an uptick in like hacker adoption of USB-C. Like there's, we've seen people converting their I got a favorite gaming mouse or whatever that didn't come in USB-C, so they converted that stuff over. We've seen that for a while, but we're really starting to see now even people, they're doing new hardware. They're making their own devices, and increasingly they're having USB-C connectors on them instead of something older. And it's cool to see, and it is a little bit trickier. There are more things. It's not like the old days where you just plugged in and you got 5 volts out of the USB port and that was it. There are a couple hoops to jump through, but even those are, once you know what they are pretty minor, and they're all well documented. And even we've got our own series of USB-C hacking that Aria has been working on, which are excellent if you're looking for a primer on how to actually, get into this stuff and build your own USB-C devices and how things are negotiated. Or it's finally making good on that promise where USB power delivery works pretty much across the board with a wide array of devices, and you can have one charger for all your stuff. I know I do. I have one USB-C power delivery charger, like in my bag when I travel, and everything from, phone, the Kindle, the laptop, everything uses the same interface, and it's pretty cool. And doubly so, I'm excited to see that, hackers and, DIY hardware is starting to adopt that same kind of standard. And I think I'm not alone, right? In dreaming that we can have everything unified with one charging standard, and it seems like we're finally on the cusp of that. So I agree with Jenny. USB power delivery is new technology done right. Although I'm sure there will be dissenting voices out there somewhere.
Here. I'm with you. And usually Jenny is kind of a new technology curmudgeon. And so it's actually really awesome to see her coming out slinging here for something that is on its face complex. But the complexity is actually kind of necessary to do what it actually does. And that is get, one plug, one standard that works with all sorts of different power delivery scenarios. A long time ago, actually, when Richard wrote his first USB-C one, the art we got Joe to do on that was a one ring to rule them all thing. And he's got Gollum there with a USB-C cable around his finger. It's lovely, right? That's the dream, and it's now kind of the reality of it. But at the time, I was kind of siding with a lot of people in the comments who were like, just give me a barrel jack. Why bother with this? The answer, of course, is that, you need a 5-volt barrel jack and you need a 12-volt barrel jack. And because there's positive tip and there's negative tip, and because you don't want to fry this, that, or the other, they have to all be different sizes. And then, boom, you're in this kind of Tower of Babel of dongles scenario again, right? And that's kind of the promise of USB-C. And I agree that power delivery has gotten us out of that. But I also do have to agree that it sucks if you want to put it on a device of yours, that you have to spend the 50 cents or $1 or whatever to get a trigger board to make it work and to get the right voltage. On the other hand, once you've given up and ponied up for 10 or 12 of these things for $5 or $6, then solder the right jumper bridge on it, the right solder bridge on it, and boom, you've got 5 volts or 9 volts or 12 volts or whatever the heck you wanted. And that's really awesome and really simple. And plus, you do have to admit that connector's nice. It holds together well. It's small. It's a good connector standard. I'm totally down with that. So I'm willing to give it up. I think I'm in the same category here. I think I'm like Jenny, formerly curmudgeon-y about USB-C, and we haven't at all converted everything to USB-C. I've got literally every flavor of USB plug on my desk here. My audio interface is running on mini. My phone's all charged with micro. I've got a piece of synthesizer gear here that has a USB-B plug on it. The one that's like square but with the edges rounded off. Like it's USB 2B. I don't even know what that is. Connects up to another piece of synth gear that has USB-C on it. So I have to have this like Frankenstein of adapters going in there. Anyway, don't get me started. I am living in the USB connector zoo here, unfortunately.
The multiverse, the USB.
I'm definitely my own personal multiverse. But if I could, I would be totally happy to move it all over to USB-C /PD and just walk away from it all.
I mean, that would, you mentioned those trigger boards. That would be probably my recommendation for anybody who's kind of looking to get their feet wet, and is just go and buy a pack of those. I know I have a handful on standby, and it just, if I see something that needs to be repowered, I'm like, I know what I'll do now. I'll use this USB-C trigger board, stick it in there. Like I said, you hit the little jumper for whatever voltage you want, and be done with it. I'd have to say that the availability of those is a big part, I think, of why there's been kind of a hacker acceptance of this thing. Like if the trigger technology was so expensive and complex that we couldn't implement it, then I think that would have really sucked. But the fact that you can get one of these things for so cheap, I mean, I see them on AliExpress all the time for like comical cents.
Yep.
For these things. So, I mean, definitely grab some of those and just give it a shot. You might be surprised how nice it is just to be able to pick, okay, I need 12 volts, and you just hit that little jumper and you like you said, solder the leads onto it, and now you have 12 volts from pretty much any modern, laptop charger or whatever.
Yeah, and on the other side, being able to say, I want 3.3 volts is a, 5 volt to 3.3 volt buck converter that you don't need to go out and buy. Like, you always end up needing to turn one DC power level into another anyway. You might as well admit that and just like head it off at the pass, right? Get one of these trigger boards and get it to give you the voltage you wanted in the first place, and then you don't have to worry about the rest of it. It's not an extra thing, it's just changing the thing.
And it's impressive the amount of power they're pushing through this thing. I mean, obviously like laptops are now charged for it. I've got a USB-C reflow plate. I mean, admittedly it's small, but it's, it uses the same cable as my laptop does, and that's pretty cool. So it is really impressive how much they're able to push through what appears to be, these thin gossamer connectors. But
well, you got to get the right cables for that, right? Which brings us admittedly to the Achilles heel of USB, which is that data rates and power throughputs and all of that depend on the cable you've got. And that's, as far as I could tell, entirely intransparent to the end user.
Yeah, I mean, I would definitely in the kind of getting my stuff together and figuring out what worked. I definitely had a cable that would charge my phone, but not the laptop, right? Because the laptop was asking for more power than the phone was. So that is a little, again, you're used to the.
I have a special cable that works with my camera.
Yeah, right.
And I just keep it in my camera bag because it's the one that works with my camera.
Yeah, and so that is a little, we went from, again, the relative simplicity of, like USB 2, where other than like the weird power-only cables or whatever, pretty much anything works with anything. A cheaper cable is not, it's not like you're just paying for the name. You know what I mean? Like,
that's right.
There is a reason that some USB-C cables are more than others, and it's not just marketing, and it is something you need to pay attention to. And we've covered that too, like head-to-head comparisons of different cables. So one more thing to consider in the already complicated modern life, but still, on the whole, I'll take it as a win.
The ability to plug a soldering iron into USB power delivery is awesome.
Absolutely.
And you can tell when you got the wrong cable because the cable gets hotter than the soldering iron tip. You
this is wrong.
Buy the $6 cable instead of the 99-cent cable, son. You need more copper. Well, bringing up the rear for me is a hacky hack breaking the flash encryption feature of Espressiv's microcontrollers. And this is some work done by Cork and a fantastic write-up of his investigation of the flash that stores the code when you're using an ESP32. And if you think about it, all of these chips actually store the code off-board on a separate flash chip. And to make that at all secure, that means that the code has to reside encrypted on that flash chip. Otherwise, someone else could just, desolder the flash chip and read it. And that's what he's interested in looking at here. So it's encrypted code that's going to write on the ESP32 that's encrypted when it's stored off-board in the flash. So he starts off by replicating a known power correlation attack with the ESP32, and this is a great primer if you don't know how these power correlation attacks work. He does a great explainer here. Basically, while it's doing the encryption, it takes a tiny little bit more power to switch a 1 to a 0 or a 0 to a 1 than it does to leave a 0 a 0 or leave a 1 a 1. Even if the encryption routine is trying to do extra calculations to get around this, just the simple fact that it doesn't have to flip bits in memory can make the power consumption different, and that opens up these correlation power analysis attacks. And that's what he's doing here. And so he starts off with a regular old ESP32, the ESP32 version 3, verifies that he can get the same result here, and then starts working on 2 new ESP32 parts. That is the ESP32-C3, which used a much longer key for the encryption. So instead of using 128-bit, it used 256-bit encryption, and he was wondering, can I get into that? And the other he wanted to look at was the ESP32-C6. I think it uses also another round of encryption or something that's meant to make it harder to do these kind of power correlation attacks. He does find that the 2 more modern chips are a lot harder to get into, but he also does find that he's able to do these correlation attacks on them. He, of course, reported this to Espressive, and, this is stuff that's baked into the hardware, and they can't fix it yet. So that's kind of where we're at here. But at least he made them aware of it, and they can start to work on fixing it for the next Silicon round. Now, if you're worried about your ESP32 projects, probably don't. This is a very dedicated attacker who has physical access to your device, can take it home and completely reverse engineer it. And, what they're going to get out of this is the code that you run on the chip, right? So if you have secret strings in there or something like that you don't want them to find out, that's kind of the worst case scenario here. Doesn't really apply to me. All my code's up on GitHub anyway. If you want to reverse engineer it, save you the work. But the other thing that I thought was really nice about this, besides the super write-up, is that he makes these testing harnesses to do the power correlation analysis, and they are absolutely beautiful. And the part that I love the most is the use of a card edge adapter, and he makes these little ESP32 memory snooper cards that all slide in there. And so it's the ESP32, it's the memory chip, and they talk to each other, of course, because they have to, but then the signals are also broken out to the card edges along with the power lines, and there's a little bit of a resistor in there so you can measure the current across it. It's an absolutely beautiful setup to do this kind of reverse engineering work. And I think earlier setups to do this cost, many hundreds, if not thousands of dollars. And here he's doing it with one of those ubiquitous Cypress easy USB chips, the FX2 chip. Makes an open project as well. So if you're serious into reverse engineering and need to do some power correlation attacks on chips, this is kind of an open framework for you to work on that as well. And so, really cool discussion of how you do the hacking, but also a super sweet hardware framework to actually carry it out.
And you see he's got that USB-C port on there too. It's happening.
Yeah, see?
We're seeing it happen live.
Here is the future.
Yeah, that cartridge approach is super cool. I love those little cartridges. I want to see them used for more than this. I don't know what, like some kind of little game system or something could use those. What a cool idea for testing out different hardware. If the other one was forced documentation, I guess this is like forced open source compliance, because at the end of the day, we're going to see what the code is. Anytime you have local access to something, I mean, the game is pretty much up, right? If you're in a situation where an attacker can literally take your device away off to their hardware lab, I hope you have a B plan, because eventually it's gonna succumb. And again, this is a really cool look at the power analysis. So there's really incredible stuff they're able to do with the power analysis, but also the power glitching and that kind of thing.
Yeah.
Where you shorted a couple volts during a critical moment and it forgets to apply the encryption or something like that. It is, talk about a wild way to get into these devices. But it's, I guess thinking outside of the box is sort of the name of the game when you're doing reverse engineering like this.
Despite what I would characterize as heroic efforts by the chip manufacturers to keep data on chips from being looked at. And we see this from all of them, the ones with programs that are stored on chip flash, right? There's always these read protect things there, and hackers always get around them. And the ESPs have the flash offboard, but still, it's the same story, right? It's if you have secrets hard burned into your flash, it gives people who have hands-on a chance to get in, and it is a cat and mouse. And I actually think it's pretty impressive that to get into the C6 chip, he couldn't just do the power analysis, but also had to do glitching, like you mentioned, to even get to the phase where he could do it. And, I do have to say that this is cat and mouse, and both sides are working hard on, getting in and keeping you from getting in. So if you're storing secrets on a device that someone has access to, they'll probably get at the secrets eventually. But it's also a super hat tip to the silicon manufacturers who are making it this hard to do it in the first place. Like they're really doing their bit too. So it's I don't think it's as easy to say just kind of snarkily, oh yeah, well you shouldn't have put the secrets in silicon anymore, because they're really trying to make it so you can store those secrets in silicon. But on the other hand, hard-coded passwords are hard-coded passwords, and somebody determine's going to get it.
And I also remember, it reminds me of the story we did a couple of years ago where people were finding that trashed smart bulbs had recoverable Wi-Fi credentials on them, right? So if you're wondering like why it's becoming desirable to hide data on these things, like that's kind of part of the problem. When every light bulb and toaster and toilet seat is connected to the internet, they all need to have, your encryption in it, and at some point you're going to replace them. So it is good that there is this cat and mouse, because it is important. Like at the very least, it's got the keys to your Wi-Fi kingdom. So it is important that this stuff is secured and that it's tested and improved. So even if you're not trying to hide your source code or anything, there's definitely reasons that you want this chip to be as secure as possible, even for a hobby project.
Yeah, I'm always on both sides of this fence. I find myself always at odds with kind of both groups, right? Like the security people are always like, nobody should be able to read anything, and I'm like, but I want to hack on it. And then the hackers are like, we should be able to read everything, and I'm like, but I don't want jerks to steal my stuff. And so, there really is this tension here, and this work is playing into that. But if you want to have a look at where kind of the cutting edge, where the battlefield is right now between the securities and the breakers, this write-up from Cork will show you, at least in microcontrollers.
All right. Well, this next one is something I hadn't seen before, and maybe it's new to you out there as well. This is the article's laptop memory upgradable again. And at first glance, I thought this was going to be somebody tackling their cheap laptop with soldered on RAM, which is, if you've looked at laptops recently, it's becoming worryingly commonplace for everything to be soldered in. And it's not exactly that, but it is a potential way forward where we won't have so many soldered-in components. And the article is about compression-attached memory modules, CAM, C-A-M-M, that are a new form factor for RAM. I mean, I think probably it's fair to say, if you're listening to this podcast, you've seen a memory module from a desktop or a laptop, and they have the edge connector, and you push them in at an angle and they snap in, and the problem is that connector takes up space and costs money. So a lot of newer machines, especially the ultra slim ones out there, have just taken it out and solder the RAM in. And of course the downside of that is it's not as easy to upgrade as it used to be. This new approach still does away with that connector, but now there's a sort of ball grid kind of patch on the motherboard where this module will screw down flat onto, so you don't have to have such a thick machine to take into account that angled RAM or anything. It bolts down, and it's a little bit more like an NVMe kind of drive. Even the NVMe drives had a little edge connector. This is just basically two PCBs just mate tightly with screws. It's an interesting story. Apparently, this started popping up in Dell laptops some time ago, and there was at first some concern that it was like a Dell proprietary memory format, and the pitchforks were brought out and the fires were lit. And it turns out, no, that Dell was just an early adopter of this standard that now other companies are starting to use. And I guess it seems like this is something that we're going to see more of. Certainly not on the desktop. It's not going to replace the traditional RAM interface, but maybe on laptops and machines that need to be thin and light, we could see more of this. Ultimately, you still have to get these companies on board, and it's still going to be cheaper just to solder the RAM in. It's always going to be cheaper to solder something on than make it removable, right? Hopefully with some pressure from consumers, we can at least take this middle ground. If we're not going to get the old school proper RAM, at least we can try to get this new compressed version that has kind of like a best of both worlds approach, where it's still cheap and thin and a good choice for these new modern machines, but still gives the end user the ability to upgrade it and get more life out of their investment, which is of course very, very important to communities like ours, where we are. Some of us are still using 10-year-old ThinkPads. That we probably wouldn't be able to if we couldn't have changed the RAM, right? Like, so making sure that upgradability is still viable even in this era of ultra thin ultra books, or is very important, and hopefully this takes off.
I have to admit, I am like a number of people in the comments. I found the name of this completely misleading. Compression attached memory modules. When you're thinking about memory and compression, you're thinking about compression and like compression attached. I'm like, oh, so it's got a compressor. It's got some kind of like a zip sort of thing on board, right? No, it's attached by compression. You put the thing against
like squeezing.
You squeeze it together with like a whole bunch of little, ultra flat pogo pins. And that's what makes the physical contact with the board. It's compression attached. I missed that on my first read through too.
If you've changed your processor, you're probably familiar with that, array of itty bitty connectors. And it's much more like that, up to and including the forced pressing it down onto the board like a processor would have. So in a way, it's almost like a unification. We're already doing the same thing for swappable CPUs, roughly interface wise. So why not do the same thing for memory? So there's kind of a nice symmetry there, I suppose.
If Dell is one of the early adopters, it has to make you think that there's some cost advantage in it. And that probably is configurability for them, right? Like if they're making motherboards, but then they want to sell an 8 gigabyte, 16 gigabyte, 32 gigabyte, 64 gigabyte RAM version of it, they can't be soldering that in there because then they need to solder it into these different motherboards. And that's a different step. And I imagine that it's easier for them to just, screw the right part in. It might be some kind of a just-in-time manufacturing advantage for Dell along the way, too. So, I don't know. I think it's awesome that it works for us. My guess is it's being led by industry desire to make things cheaper for them. But as long as it works on both sides of that, I'm happy.
Yeah, I imagine this would be easier to install robotically, because instead of having to do that like angled insert and you push it down till it clicks and everything, now you just need basically a pick and place to drop the thing on there and just screw it down. But and again, you're not including the clip and the little metal retaining thing. So I mean, there's a cost advantage. It didn't cost them anything to print a bunch of pads on the PCB, right? So if you drop off that hardware, how many laptops out there have that little lonely empty slot of RAM that was never populated?
That's right.
Like they're manufactured with it, and I'm sure it cost pennies in volume to put that little plastic connector in there, but still, if they're going to be out there and not be utilized, that's just a waste any way you look at it. So.
And it costs space, and space is what they're really paying for inside laptops.
And that's why, like you said, you can add this expandability without necessarily adding cost or making it thicker, and it's still there for the people who use it. So I do think it's a best of both worlds. Even if the consumer wasn't the first thought, it's still a better deal than opening it up and being like, oh, cool, that's soldered in RAM that I can never change.
My first quick hack this week comes from Oskitone. Simulate running a small hardware business with Hardware Hustle. This is a pad and pencil dice game halfway between Yahtzee and Dungeons and Dragons, where you get to simulate running your own small hardware business. This is inspired by Oskitone's own Hardware Hustle, which is making small open source synthesizers. Really cool and funny take on the trials and tribulations of getting a cool project out to a lot of people. Next up, M. Sylvain reverse engineering a Russian tornado's guidance circuit board. He bought on eBay the circuit board from a missile that was landed in the Ukraine, takes it apart, has a look at it. It is full of those lovely flat pack parts, but because they're Russian and mil-spec, they're all coated in gold. It's an absolutely beautiful board, and it's actually two boards sandwiched together. Instead of having vias between the two boards, they actually have little U-shaped jumpers all around the peripheries. It's a really neat construction. I'm sure it must be for some reason. It's just a really pretty looking board. You should go watch the video. Next up, Tamid, saving PIC microcontrollers with a DIY programmer. We've seen people using the RP2040 for programmers for everything. A lot of the time it's because they have the super high-speed peripherals. Here it's not the case. He was back home over winter break looking at a 10-year-old project, needed a PIC programmer, and bit-banged it in MicroPython. He says MicroPython's 100 times slower than C, but when your code is 100 times faster than you need, then it doesn't matter. Yeah, get her done. And my fourth of 3 quick hacks comes from Damien. I couldn't leave this one out. Skip the radio with the software-defined ultrasound data link. Here he's 3D printing parabolic reflectors, mounting ultrasonic transmitters in there, and then using software-defined radio techniques to transmit data over ultrasonic sound between the two of them. And I always love these projects where radio stuff is misused for audio stuff, or audio stuff is misused for radio stuff, because it's really just different media and different frequencies being the carrier and the message. So this is one of those projects, but it's also got 3D printed parabolic ultrasound reflectors in it.
My first quick hack this week is All I Want for Mr. Christmas is some new music, and this run is about Mr. Christmas, which is apparently some old school holiday thing that played music off of little perforated discs. And the cow goes moo picked one of these up at a thrift store, sounds like, which apparently is a neat trick because these things are relatively valuable, according to the comments, and was tired of the Christmassy songs that came on its little disc, so they figured out how to recreate the pattern of holes in MATLAB and then laser cut the result into various pieces of cardboard, including a Cheez-Its box and a DiGiorno pizza box, and now you can listen to this little Christmas ornament play Van Halen and Post Malone and all sorts of not so much holiday appropriate music, but at least more contemporary. Next up is Countdown to a Spaceship Simulator. This one came from John Skagmo, and it is a very cool, rack mount thing that looks like it would be inside of a interstellar vehicle of some type. I mean, it's obviously got some NASA inspiration, and it's a little bit Kerbal Space Program, and it's a lot of bit LEDs and cool visualizations. And we're told it was built for a child, but I suspect that there was some lingering childhood dreams of his own that led to the construction of this. And I say that as someone who definitely builds stuff for my own kids, because I wish I had it when I was younger. All kinds of stuff comes together, lighted buttons, LED displays. There's a panel that shows video synced up to telemetry from real Falcon 9 launches. There's a lot of really cool stuff in here, and it appears that this is just the first module of a larger build. So definitely something we're going to keep an eye on and see where it ends up. And lastly, a Rigel scope goes wireless. It probably won't come as a huge surprise to find out that there are, high-end oscilloscopes on the market now that are running Android. I think that is becoming more and more of a thing where if you got some kind of powerful device and you want an interface, you just say, hey, I'll put Android on it. So the Rigel DH 800 and 900 both run Android, and Voltlog was wondering what kind of interesting possibilities that would open up, and in this demonstration shows that you can actually hook up a regular USB Wi-Fi adapter to the scope's front panel and add it to your network for remote operation, that kind of thing. There is a little bit of a hoop to jump through because there's no scope interface for configuring the Wi-Fi, because it was never supposed to be on the Wi-Fi. But if you plug a USB hub into it and then plug a keyboard and your Wi-Fi adapter in, you can actually open up Android's configuration menus with a keyboard shortcut and then configure it that way.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I wanted to start off with Al Williams's Ask Hackaday, Why Are Self-Checkouts Failing? This is another one that drew 1 million comments. I think 157 at the moment. And it's
Almost
good
1 million.
food for thought. It's 1 million in Hackaday comment numbers. Cut to the chase, the reason self-checkouts are failing is that actual checkouts that are manned by cashiers are devices that are run by professionals. And it's no surprise that devices that are run by professionals work better than the same device run by a bunch of amateurs, i.e., the people ahead of you in line at the self-checkout. I've suffered through all of the various woes that he brings up here at least one time. Like, when it doesn't register that you've put the thing down, or you put the thing down too fast and it thinks that the weight has increased spontaneously, or then you pick it back up to do something and it's like, oh, now the weight's decreased, and the alarm bells go off and the helpful assistant comes out to get you. Or when it's out of paper, or when you do the like membership card in the wrong order with the credit card, or arg. I'm totally with it. And I do think that it's an incredibly expensive piece of machinery. I had no idea that he mentions in this article a 4-kiosk system might run upwards of $100,000, but it's also just cheap enough that you could probably convince a store owner that they could replace 4 or 5 people's salary with this, and then it's not so expensive after all, right? But then the problem is you still have to have at least one person there to help the customers when things go wrong and to make sure they're not shoplifting stuff and all the rest. And yeah, in the end, my experience has been what's reported in this article, which is that you're not necessarily faster going through the self-checkout. I have a favorite cashier at our local hardware store, and she just knows her shit. And she just zip, 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 zip. There's no way in 1,000,000 years I could do anything that fast on a self-checkout machine as she does. And she's hyper friendly. She's just really nice to talk to for that 10 seconds. Bah, you can keep your robot checkout.
The origins of this article is the BBC report that, it doesn't mince words. It says that self-checkouts are a spectacular failure. And they're kind of annoying. I don't know if I would have described them as a spectacular failure. They certainly have their downsides. But then I suppose I never really thought about it from the business standpoint of it, where if the business logic is that you replace workers and therefore it's cheaper, I guess I could see that being a failure because if you're costing that much up front and you still have to have somebody to babysit them, what is the time for payoff? It's not looking good, right? Especially considering what realistically a cashier would probably be making anyway. And then you add in the aggravation of when it doesn't work, and I still don't know if I'd say spectacular failure, but I can see it's definitely not an ideal technology. And reading this, it reminded me of there was a commercial years ago. I don't even know what it was for now that I think about it, but I remember it had this real, shifty looking dude, and he had a trench coat, and he was going up and down the aisles, grabbing stuff, and putting them in his pocket. He goes out the front entrance, and the security guy stops him. He's like, "Sir," and he turns around, and he was like, "You forgot your receipt." What you didn't realize at first was that everything had RFID tags in them, and he had walked through this turnstile thing that instantaneously scanned everything in his pockets and charged his account that was on file and blah blah blah. It was probably a commercial for some tech company that facilitates this sort of integration, right? But I think that's probably the kind of technology you would need for it to really be what we're hoping for in self-checkout, right? You just grab the stuff and go out the door, and somewhere along those lines it gets scanned and it just comes out of the account you have on your phone, or but that's very, very far from what we're doing now. We are, like you said, taking a machine that was designed for a skilled, trained operator and just saying, give it a shot. You can probably
Good
figure
luck.
it out, right? Good luck. And,
I actually went looking for it because I think we must have even written it up on Hackaday, but there was an Amazon sponsored, so probably implemented at Whole Foods, approach where they were filming you everywhere in the store and using image recognition to watch you put a head of lettuce in your cart. And then they charged you for it when you went out the door. And that was kind of like the RFID tag one you want to implement, but it was the computer vision version of that.
Right.
And either I dreamt it or we didn't cover it because I couldn't find it anywhere. And Amazon doesn't mention it anywhere either, but that may be because it was a failure. And they're pushing now exactly that RFID technology that you want. You know, you can walk out these little cow corral chute like door things and it'll scan all your things and check you out for it. And that is probably the only reasonable automated solution. I think the other thing that came out of Al's write-up for me was that theft doubles in the self-checkout aisle versus the cashier checkout aisle. And that doesn't always mean that it's mischief, right? Like it could be many, many more accidents, or the machine doesn't scan things right, or there's just a whole bunch more failure. And part of that's because there are fewer eyes looking at the problem, right? Like if you have a human cashier, they're scanning everything through, right? And they, you know, maybe they look in your cart and say, oh, you forgot that pack of gummy bears or something. And then you put it up on the thing. You weren't trying to shoplift gummy bears. You just left it in your cart. Not a true story, didn't happen to me, but could have. But, you know, so there is kind of this second, there's just an extra pair of eyes looking at things to make sure you don't forget anything when there's a human cashier in it. So doesn't surprise me that shrinkage gets reduced.
We can talk about awkward self-checkout stories. This was fairly recently. I was at the grocery store and I swiped my frequent shopper card and I did all my stuff and I was distracted. I think there was a noise or a flash of light. It doesn't take much to distract me, and I missed the critical step where you actually pay for the groceries.
Oh.
But then put all the stuff in my cart and went in the car and drove home. And like before I even got in the door, I got a call from like the I guess the manager at the grocery store, and he was like, "Hey, are you Tom Nardi?" And I was like, "Yeah." And he's like, "Did you go to the grocery store today?" And I was like, "Yeah, I was just there." And he's like, "Did you maybe forget to pay for everything you purchased?" And it was this very awkward phone because he didn't want to like say, you know, "You thief, bring me all the groceries back," right?
Yeah, right.
And I was just so mortified that I was like, "Yes, I'm very, very sorry. I did do that." He was like, "Well, can you come back and pay?" I was like, "Yeah, of course." And he was like, "Now." You know, like
before we call
now,
the cops.
Before, right, like not tomorrow morning or like when it's convenient, like right now will you come back and pay? And you know, the funny part, of course, is that I had used my little frequent shopper card, right? Like, and I even told him when I got back there, I was like, obviously I wasn't trying to steal this. I wouldn't have given you identification before ringing everything up if I intended on stealing it. I am just a fool. Yeah, okay, maybe they're a failure. maybe
you must get that all the time.
Maybe there's some room for human error in there. The interesting takeaway was that it let me take the stuff off the platform without paying for it, which is kind of weird because usually when you take the stuff off, it'll say, "Hey, dummy, put it back on." And it did not, obviously. You know, it let me leave, so I thought that was kind of, I don't know if the sensor was screwed up or something, or...
That's awesome.
I'll blame the hardware. It's at least partially the hardware's fault for letting me do it. Why did you let me do this, hardware? Well, my pick for a can't miss article is Dan Maloney's Sun on the Run, diving into solar with a mobile PV system, photovoltaic. And I thought this was just awesome. I always really like to see what the writers are up to and what they're working on, and I think it kind of gives us some credibility, right? It's proof positive that we're not just a bunch of differently named Python scripts that are pulling in articles from the internet. Like we are proper homegrown nerds, and we're working on our own stuff when we're not working for Hackaday. And this is, I mean, a pretty substantial project from Dan, where he was looking to do solar, and his house, for various reasons, wasn't a great fit for the panels. There's trees, and he doesn't, he didn't want to put panels on the house. So he got the idea of putting them on this utility trailer and making like a mobile solar power station and it's just awesome to see how much work he's put into it. I mean, everything has been changed. He rips the whole inside out and he insulates it like a house because he wanted to keep the batteries and the electronics warm. He goes under there and puts sheet metal over the whole bottom of the trailer because sometimes you get rodents and stuff that want to come in there and eat your wires and ruin all your investment. I mean, he really did put a lot of thought into this before there was even one panel mounted to it. And that includes this winged deployment system that looks like it would be, on a spacecraft of some type, because the trailer obviously only has room for like 3 panels on the top, right? It's just like a regular rectangular trailer. And so he has these wings that deploy that hold extra panels, but he found out the hard way that they were too heavy to lift. So he had to develop this screw jack system with like a motorized thing that he welds all together. I mean, there's a lot of ins and outs here, and that all happens like before the first wire is stripped. Like there's so much of it is mechanical in nature, and figuring out how much the panel is going to weigh, what kind of materials can I use. At one point he was going to use 80-20 aluminum to make the wings for the solar panels, but then he realized that he could get a metallic conduit from the big box Home Depot kind of store for, if not cheaper, at least way more accessible, right? You just go to the store and get whatever length you need. Plus it's galvanized, so it's cool for outside. You don't have to worry about that. So he goes through this first half that's mechanical in nature, and then switches over to the electrical part of that, where he's using, the batteries are repurposed like server battery backups, but not the little, one you get at the Walmart for your desktop. Like these are serious data center, like 48-volt lithium power packs that apparently retail for quite a bit, but you can get them on like the secondhand market and repurpose them. It's just really a really cool rundown of, not to say you would necessarily follow this. It's unique enough that I don't know that anybody else would follow it exactly, which I guess is kind of the case for a lot of the stuff we cover on Hackaday, right? Like a lot of it is so bespoke that it's unlikely somebody would copy it exactly. But there's absolutely going to be stuff in here that is inspirational, that you're going to learn, that you could apply to your own design, and whether it's the solar side of it or just, how do I refurb a utility trailer to make it, a mobile command station. Like there's just a lot to take in here, and I'm glad that Dan did write this up. I know he'd been talking about it for a while, kind of threatening to write it up, and I'm glad to see it finally kind of come all together. And I think I now want a solar trailer of my own. I this is the strangest thing I've ever been jealous of. Maybe is his mobile solar power station, but it definitely is a very, very cool final product. And he even says in the write up, it's kind of thing that people ask him all the time, because it sits in his driveway, and he says people just come up to the house and be like, "Hey, what's that thing in the driveway? Like, can you tell me about it? Like, how'd you build it?" And now he can send them to Hackaday to find out. So that's always good.
I mean, I hadn't thought about the downsides, like you want to keep the batteries warm, and that's something you don't have to worry about if you're doing like a solar installation with batteries in your basement, because your basement isn't going to get, too far below freezing. On the other hand, it offers so many extra options if you can do it off premises in a trailer. Like the fire hazard, he could have used significantly sketchier batteries than he ended up doing, because so the thing does turn on fire, big deal. It doesn't burn his house down. Just
right.
Lots of melted
fire
pink foam inside his sketchy trailer. No, and I love the mounting system and everything, and the fact that you can, flatten and angle the solar cells means you can actually put them at, kind of the right angle to receive maximum solar illumination, which is not always something you can do unless you're really lucky with the way your roof is situated in a house. Like this lets you move the solar to where the sun is in a way that it doesn't if you're stuck to putting it up on your roof. But also, because he can flatten them back down again, he can actually drive this thing around. Like it's got legs. I mean, there's got to be, if you're having a block party, you could pull this thing up and you could power the whole event, right? Like
absolutely, right.
This could be hella fun. Like he needs a big badass sound system, and he could drive around throwing random raves everywhere. He just some laser projectors and a bunch of speakers, and he'd have some.
And he mentions that too in the write-up that there's the potential that he's going to buy, some very rural property in the future that's not grid connected too. So there's the potential that this is going to be the power station kind of for that, right? Like, so right now it's like you said, it's the workshop.
Right.
He's using it around the house, but because it is a trailer, he could be like, hey, all right, let's hitch it up and take it to, the middle of the woods and
drive it out to the cabin, and then you're set.
Build the cabin potentially if you're talking about something that, remote, there's probably nothing on it,
Yeah.
right? So yeah, it's definitely it's an investment for sure, but I think it's really I think it's gonna be well worth it. And he says at the end that he doesn't want to total up how much it cost because he thinks that'll take some of the fun out of it, and that's always a wise precaution with a large project like this. But I think there's no way it costs more than what a commercial. Well, first of all, there probably is no commercial offering that's directly comparable, but I don't think there's any way it cost him as much as something that was purchased turnkey. I mean, he definitely saved money by doing it himself.
That does it for this week's Hackaday podcast. Thanks very much for listening. If you'd like to follow the links, head on over to hackaday.com/podcast. Check them out and leave us comments while you're there. If you see anything cool or do anything cool, send us a line, tips@hackaday.com. And until next week,
keep on hacking. Beep, 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 beep.
Beep, 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 beep.
Oh, wait, what have they done to Google Docs or Drive?
Dude, I think I covered this last week.
Well, that's what I get for not listening last week. What was the last thing I said that wasn't stupid?
Super. I think we're good.
Yeah.